Hey pre-calc, so these are your 1.7a notes for inequalities. For the first inequality we have 3x is less than 9x plus 4. This is pretty standard. We need to get the variables on one side. On these problems, it's generally good form to get the variable on the left because when we read the final sentence we're going to want to say x is either less than or greater than some number. So if I want to move the variables over to the left, I'm going to take away 9x from both sides. Subtract 9x from both sides. I get a negative 6x is less than 4. And then I'm going to divide by negative 6. Now, whenever you multiply or divide by a negative, you have to remember to switch the inequality from a less than to a greater than. And so we get x is greater than, let's see, negative 4 over 6, I can reduce to negative 2/3. And so my final answer would be x is greater than negative 2/3. Now, on a number line, if I were to graph this, I would put negative 2/3 down. I would use an open circle, and I would graph everything greater than, so we'd be shading above. Okay. For the next, since we have a quadratic, we need to get 0 on one side first. This is important. So I'm going to write it down. Get 0 on one side. And actually, the preferred side would be the right side to have 0 on. So if I want 0 on the right here, I'm going to add 6 to both sides. And I get x squared minus 5x plus 6 is less than or equal to 0. Now, the second step is going to be to factor. Okay. So most of these will factor. If it didn't factor, you could always find the zeros later on by using your graphing calculator or the quadratic formula. But for this problem, we're going to factor. So let's see, we get two things that multiply to 6. So what times what is 6? Well, it's probably 2 and 3, I think. And then I need them to add up to a negative 5, so they're going to both be a minus. So a minus 2 and a minus 3. Okay. After I factor, I want to find the zeros. Now if it doesn't factor, you just skip straight to finding the zeros. So let's see, x minus 2 equals 0, and x minus 3 equals 0. Notice I'm setting these actually equal to 0. And then I solve, so I get x equals, let's see, 2, and x equals 3. Okay. After you find the zeros, if you're going to do this algebraically, you need to set up your table. Okay. So the table, well, let's see, the sides of the table are going to have your factors. So x minus 2 and x minus 3 are my factors. And now the top of the table, we need to have intervals, and we saw this in class today. Now the way that you get your intervals for the top of the table is if I take my zeros, x equals 2 and x equals 3. Basically, I want to know what's happening between negative infinity and 2, between 2 and 3, and also between 3 and infinity. So my first interval is negative infinity to 2, and then 2 to 3, and then 3 to infinity. After I get my table set up, the fifth thing I'm going to want to do is test numbers in my table. So I'm going to look at this first interval and think of a number that's between negative infinity and 2. So I guess I'm going to pick 0 because I know 0 is in that interval. If I think of 0, 0 minus 2 is negative 2, so that's a negative number. 0 minus 3 is negative 3, so that's a negative. And now since the original problem, I'm multiplying these two factors together, a negative times a negative is going to give me a positive. A negative times a negative is a positive, and it's because I'm multiplying these two factors up above. Now I think of another test number between 2 and 3. Let's go 1.5. 1.5 minus 2 is still negative. Just joking. 1.5 isn't in this interval, but 2.5 is. So 2.5 minus 2 is positive, 2.5 minus 3 is negative, and a positive times a negative is a negative. And then a number in this interval, let's pick 4. So 4 minus 2 is positive, 4 minus 3 is positive, a positive times a positive is a positive. Okay. Once you get your table filled out, you're in the home stretch, you just need to identify your solution. So Let's see, I look at the original problem, and the original problem is asking me for less than or equal to 0. So less than or equal to 0 is another way to say negative. And so what I'm looking for in my table is the place where the overall problem was negative. So that's right here. Now the place that corresponds with that is the interval from 2 to 3. So my answer is from 2 to 3. And now the last thing I need to do is just make a determination about whether to use parentheses or brackets. Since this is equal to, less than or equal to, I should use brackets. Okay. Now this is how to do this problem algebraically. If you were to graph this problem, you would see a parabola with zeros at 2 and at 3. So you would see a picture that looks kind of like this guy if you were to graph it on your graphing calculator. And to be negative, or to be less than or equal to 0, would mean to be below the x-axis, because that's where numbers are negative. And so sure enough, our graph really is below the x-axis between 2 and 3. That really is where the parabola dips below the x-axis, where this graph is negative. Okay. On this same sheet of paper, on your notes, so I'm going to have to switch because I've been writing nice and big. If you guys still have room on that same side, that's great. If not, flip the paper over. On the same side of paper, I'm going to have you guys do 2 extra practice problems on your own, and we're going to check the answers tomorrow in class. So would you please do, this is practice problem number 1. This is in your notes. Would you guys please do x minus 5 times x plus 4 is greater than or equal to 0? I want you to do this with the table method and also by graphing. And then practice problem number 2. Would you guys please do x squared plus 2x is greater than 3. Okay, and I want you to do both of these with the table method and also by graphing. And then we will check these off tomorrow when I look at the notes. Thank you and good night.